students are sending emails asking for access code. That's not if you have missed for a valid reason, you can just ask me. I'll tell you those two. It's a week over, but still I can tell you on the very first one. For self-intro, it's a self-intro 0. That's the access code.
All small?
All small with 0.
Zero.
You were not able to do it's due next week, right? I think
yes.
Yeah. So I don't mind. Let's see this. It doesn't. This so self-intro 0 is the access code for your intro on quiz 0. Okay. Sorry, that's and quiz 1. What's the access code?
Syllabus Q.
Syllabus Q, right? So that's the access code. I can tell you in class, but do not ask other friends about that. So Q1 is syllabus. Okay. So if you have any reason, come and
Self-intro Q.
talk to me to get the access code. Do not ask TA or other students to get the access code. Okay. I'll tell you later again. Today's quiz access code is a W, capital W and 2. Usually I don't recall my access code. I'm impressed by myself. I'll tell you again.
And there's a Q1.
What's that?
There's a Q1.
No, it's no Q1, just Q.
Okay, this above the syllabus?
Question 1, the quiz 1.
Okay.
Yeah. So, that's the no asking access code to other students or kids. So let's talk about the cloud computing user visible side of characteristics, especially for this is not shown. Sorry. So. Characteristics are actually those that we have talked about before. That includes on-demand access. That's what we see. Resource is available when I need it, and I can, as a user, I can, get the surveys without talking to any IT folks. And the resources can go up and down fast, rapidly at any time. There's no 9 to 5. And also, as long as the internet, raw, the network access is available, it is accessible over heterogeneous platform. And also, user visible SLAs are there, like the how much in terms of performance, availability, and also user visible SLA in terms of payment as well. If I use this much, I'm going to use this much. They do metric usually as a user. You believe what they say, and that's what we pay. So these are the characteristics from user side, from outside, especially for public clouds. Pay as we go. Only pay proportionate to the resources that we have used. But the properties, characteristics behind cloud or inside of the cloud can be different. What do you think? The user visible characteristics all cool, great things, right? All great things. And in fact, data center does a lot of paddling under the water, like the swan, duck on pond. They may look very gracious, calm, but underneath, a lot of things happening. What do you think? What could be happening that user doesn't recognize?
Can you rephrase the question again? Like,
So some of the things, properties, characteristics that happens inside a cloud that doesn't
affect the user?
That doesn't look or that doesn't appear from the user side. So like the swans, ducks on the pond, they look so gracious, calm, but they just go through the water without any problem, smoothly. That looks like, but underneath, it does a lot of paddling, right?
It's user data collection,
Data
collection,
data
processing.
collection. Okay, yeah. The usually through the agreement, right? So it's not completely invisible, but that's a possibility, right? Yeah. Security issue. So security issue, that can happen. Yeah. But it's also still when that happens, a lot of the compliance law says that we have to inform the users, right? Without knowing, without you may not know that, but we had a data breach, last week, and your SSN was revealed to, so to get those mails out occasionally. That does happen. Anything else? Scalability, yeah, it goes. You see that the performance is going better, and maybe it's actually performance doesn't look impacted regardless of the number of users, right? So yeah, the user scaling up and down would happen behind the scene inside the cloud. Anything else? Actually, I have listed these things. The scalability, right? The one we just talked. And another thing is that multi-tenancy or resource pooling. Users might feel that resource is dedicated towards me. I'm not sharing anything. All the files that I'm putting on this folder or on this, the bucket, it's not impacted. I'm sorry. Let me take it back. It's not this place co-used by anyone else. However, from cloud computing provider's perspective, it does pooling of resource and it does provide some isolation, seemingly to individual users. However, it does multi-tenancy, as I said, like an apartment user might feel that there's some isolation, but gyms and a lot of infrastructure underneath are being shared, right? Even computer, the physical server, there are a lot of virtual machines are generated for individual user. User think that that's an entire machine dedicated for me. However, in reality, multiple virtual machines are co-located on the same server doing the resource pooling. Also, data and tasks might migrate. User might not realize that, but the migration of the task or processes and data can happen from one node, one server to another one. What could be the purposes of doing this migration? Moving data from one server to another server. What could be purposes? There can be many different purposes.
To buy and sell data.
I'm sorry?
To trade, buy and sell data.
Mindset?
Migration.
Storage, maybe.
Storage allocation.
Yeah, so the storage, the content of the information, data are being migrated from this node to another node. What could be the purposes? Why would they do that?
Make system highly available.
To make the system
Accessibility.
better available, accessible. If you don't do that, it might not be available or accessible. Like, that means
Like if the single server is down, data is not accessible.
exactly right. Yeah. So you don't want to overload the server too much. So you might want to do load balancing. Load balancing can be one of the the purposes. Any other purposes you can think of? In fact, there has been a lot of researches, including our lab. They theoretically we can set it as an optimization problem. You wanna maximize or minimize this goal with this constraint, right? So what could be the goal? And you can also think about what are the constraints of physical resources, right? What could be the goal of the optimization problem? Load balancing, that could be one of the goals. The other goals you can think of. Let me give you
Can I say something like it's a we can store the data and other servers like RAID processing. I heard about it. The RAID.
So we are going to talk about the RAID storage different, for reliability purposes.
Reliability
right?
purposes.
So, you mean the reliability purposes? Typically, what we do is the replication, right?
Yeah.
Redundancy. So that's also, we do that.
This is not
Migration is moving from one
okay.
to different places. One purpose can be actually, reduce the energy cost. Okay. If there is only one VM running on this server, you can move it to somewhere else and put that machine on a, put it down or on a standby mode, right? So you can, and also a lot of the servers in entire rack, if you can empty it to a different place, then you can also save the more energy there. Yeah. And also some different cities or different data center place, it doesn't impact the performance too much. You might see that, why don't we just run during the daytime in this data center where the electricity bill is lower, right? So that can be the migration purpose. So you can think of actually many different purposes, and that's kind of a secret, the recipe for the providers to do their work better. Question?
Actually, in servers there will be a lot of heating, right? So
yes.
Instead of for cooling those servers, we will migrate the task and data.
Exactly, right. So the energy purpose, you put it down, and if you can, in an extreme case, entire floor or building site, you can, save the heating and cooling, the energy cost. So for performance purpose, you might do a load balancing, and given the performance goal is met, you might do the energy, the optimization. You can also do, the energy optimization on a small scale or a bigger scale, per city level. Per site level, or per, the machine rack or floor, things like that. Right? Or actually, it can be for, policy. There should be this data. We just hear that it cannot be in this country. We have to move it to a different place. That's also possible. Yes.
Could security be one of the reasons?
For security, could be the reason.
Like data should not be present in one specific space. It can be distributed. So if one of the servers
right.
get attacked.
For security, reliability. Again, that's typically for replication. So replication is a little different from migration. Migration is moving from one place to another. But for security purposes, I said for policy, this U.S. government data cannot go outside of the border of the U.S. territory. We had it over here, user generated, but has to be collected on different sites. That can be also written as well. So these things are happening inside the cloud, behind the scene. And continuing on that, the auditing, monitoring, measurement of the resource usage, while you are sleeping without your recognition, things are happening. And this is one of the most notable one. Failures. You might, see that as long as you put it in Google Drive, you never lose. But that's not the case in reality. Data, any physical system can go down, and actually that failures are very common. Many years ago, even still now, the failure data is not publicized because that harms their publicity. So most of the places, ISPs, the CSPs, the internet service provider, communication or cloud service providers, they don't publicize those data. But many years ago, including myself, we know that everybody knows that happens. Analyzing those data and coming up with the right algorithm strategy to mitigate those is an important thing for our researchers and for the providers as well. So, there has been some failure data collection and work has been done. In fact, our group has done failure analysis work from UMKC network data several years ago. And also we are working on other aspects as well. So these things are happening inside of the cloud. And there is a quiz question today. Which of the following is not the user visible cloud characteristics? Migration failures, pooling, especially those, users won't recognize it, right? So these are not the user visible characteristics, but inside of the cloud properties. Questions? Next week, let us talk about the trends. So a little bit of history. We'll talk about history a little more. The university academia, we look at the technology not as a snapshot, but as a spectrum over the time, and that helps us to appreciate. So a lot of part of your goal of this class is not just how to use it, understand it, but also appreciate the technology, and that helps you actually envision the future technologies as well. The courses in different schools, maybe not engineering, their course student learning outcome appreciate, the medieval times of things that can be the outcome. So appreciation is an important thing. You might have seen some of these in the movies. You see this is a tape, storage device, pretty big, personal computer, server, and now we have phones and tablets. The computing, now we are accessing from anywhere using mobile devices or laptops, and actually things are happening in data centers through typically as a web services. I gave you all the web link to be able to access AWS, the Azure, and GCP, right? There are a lot of providers there, Rackspace, Salesforce, VMware, Yahoo, Cloudera, and most of these days, IT companies, they say we do cloud something, not just using, but also providing as well. So there are a lot. And these are some example of services. EC2, Elastic Compute Cloud, Elastic going up and down, simple storage service, EBS, Elastic Block Storage. Later in the storage part, we're going to talk about the block, what do we mean by block versus what are the other storages. If you have looked at the storage services offered by these providers, storage services, any names? Have you you have looked at?
IBM
DB2,
IBM
Hadoop,
IBM's DB2 service.
the IBM's what did you say?
DB2.
DB2. Okay. What does it stand for? Database, block storage. Okay. So yeah, the there are other storages like file storage and object storage, basic the storage types. Database is actually a platform on top of that. So they are offering a lot of different storage services, or even compute. You have to understand just basic the technology used for those services, so that we are going to talk about it later. Compute cloud is actually virtual machine service, entire like a computer. This is the actually object storage that we're going to talk about, and this is a block storage. And just by knowing that, we see that this is a block storage versus the object storage. You can expect that there will be the pricing difference, cost difference. Block storage being a lot more expensive than the object storage. We're going to talk about it later, why that's the case and what does that mean in terms of performance. That will help you to decide which one you use for some application project you might have. We have a lot, even early on, more than 10 years ago, there has been many. So this has been all in the cloud scene from the beginning. EMC, Dell, EMC, VMware, it's all separate. Now it's combined and then separated, the kind of subsidiaries separated. But just know that it's not just three, okay? I need to broaden your horizon. This is a projection from 2009. The IDC and Gartner's are two very well-known the market forecasting research for the companies. They're in fact, in order for their yearly report on some of their forecasts, you have to be a member, and it can be expensive. But the older ones is free, and I guess people in business, they might subscribe it. You just know that in 2009, before 2011 or 2012, right, there has been these marketing forecasting firms that have forecasted the importance of cloud computing. And let's see what they have said at the time. Cloud computing heralds an evolution of business that is no less influential than e-business. E-business at that point of time, it was a big change in the way we do business, and it can influence as much as or have to be more than that, and we can represent big portion of IT spending by this year, and we actually have the data on the IT spending, and the IT spending we have actually a lot more than that, even UMKC. The IDC said that it's about the industry's new model for the next 20 years. What about after 20 years? It's not a new model. It's actually permeated into our lives, right? We call what do you call this device? Mobile phone, right? Your name? Ankita. Ankita. Yeah. She didn't say smartphone. Well, and sometimes we just say phone, right? So the successful technologies are kind of permeated. The ones that get into our lives, we don't even notice as a special technology, and that's what they are projecting. And it's the big amount of money will go into the field. That's what they have said. And also U.S. government, they have used, and many other companies, started to use cloud computing. Like a lot of government websites, it's all on the cloud. How many of you have seen this kind of cycle? This is what kind? This is called hype cycle. Hype cycle for some technology at what point of time. So hype cycle, what it says is that most of the actually technologies go through these cycle. The Gartner, we know that, and Gartner actually what they have done in 2011 is that for cloud computing, these are the cloud technologies on different areas of hype cycle. So hype cycle, on the x-axis is a time, y-axis is expectation of people, anticipation, a lot of interest, meaning big development and also big investment in terms of money as well. So this is what actually the expectation is more on the anticipation people are going into. It's not really exactly calculated as a money invested, but you can expect that people will follow this one. So there is a different stages. Initial technology trigger stage. This is a new technology that's coming up. And the peak of inflated expectation, maybe it's overly hot topic at the point of time, and then a lot of technologies goes into trough of disillusionment. Well, we thought that this is gonna be a panacea for everything, or it's gonna make a big business. Maybe not. Some of the interest gets out, but still there will be some continuation of development, and some of the technologies actually survive. A lot of technologies die out from there. Some of the technologies survives, and it goes into so-called the slope of enlightenment. This technology is getting mature, and it's getting interest in the real deployment and so on. And then later on, it goes to plateau of productivity. So time, expectation, technology trigger, peak of the expectation, trough of disillusionment, slope of enlightenment, plateau of productivity. So this is again hype cycle, and the Gartner's anticipation, the prediction for cloud computing at this point of time, not prediction, where their the analysis, this technology is somewhere. What do you notice? Tell me some of the words that you notice from here. Platform as a service was at the peak at the time. Okay.
Public cloud storage.
Public cloud storage. It's already over here. Google Drive, things like that. Yeah. It's already past the peak of expectation. Anything else?
Virtualization and software as a service.
Where is it?
There's
Slope of
To the right, slope of enlightenment, virtualization.
Oh yeah, virtualization, and there was another.
software as a service.
Software as a service. Email is over here already, very well received. Okay. Software as a service is over here. Platform as a service over here. Okay. Infrastructure as a service is over here. So software, Gmail, or Salesforce, these things were over here. Infrastructure was actually first introduced by the multiple providers, including AWS. Platform is actually catching up there. Private platform as a service, DevOps was over here. So that was this hype cycle from Gartner in 2011. 2016, it's the largest. You see that virtualization is actually really, the engine of the cloud computing. It has to be there. We'll talk about it more, but this was already matured technology. Now it's over here. Software as a service, more close to the total productivity. Platform as a service, infrastructure. All these things are over here now. And then software defined anything. Software defined the storage, everything being softwareized. That's the hype cycle in 2016. What do you think now? They don't publish hype cycle for cloud computing per se, right? But something related like a digital government technology, things are there. You can also search for hype cycle for different technologies, right? The blockchain and this is a 24 screen, so 23 is the latest kind of analysis. In previous times, I let the student to actually at least to do the performance evaluation many years ago among at least 3 different public cloud providers. And these days, there are cloud services that does that kind of comparisons. And also initially Cloudera, now Flexera does the annual report of cloud status, meaning that they do survey, not a performance evaluation, and 750 different companies, they do survey, and it includes enterprise as well as small and medium-sized businesses, and ask question, what kind of cloud do you use, and so on. So what they see, this is hopefully, it includes the diverse sectors, and this is what they see in 23. A lot of them are using multi-cloud, not just one single cloud. And there are some single cloud and the private cloud, the enterprises as well. Among the multi-cloud, they use hybrid the most. Hybrid, as we'll talk about soon, typically, so public, private, community, hybrid. Typically hybrid means that public plus private, and that's what they do. So don't think that cloud will be the only one. If you go to the industry, get a job, mostly if you do own company too, these are the things you are likely to do. Maybe in the very beginning you might use just one public cloud, but that's not what they are doing. Knowing what others are doing, help us to see the big picture. So most of the industry does the hybrid cloud, the public-private, and some may be public-public, multiple public, and some may be using multiple private. Actually, public provider may provide a public-private cloud. We'll talk about this soon, and then they might have their own, the self-managed data center as well. Actually, before I show this, what do you think? Which one would be the most popular public cloud? This is a U.S. Statistic. Okay. You saw it already. What was it?
IBM?
Was it IBM?
No, I didn't see it.
AWS?
Yeah.
I'm just
For many
AWS,
years,
yeah.
it has been always AWS, in fact. But recently, this is the first year that I see Azure, caught up with AWS. But still, the difference is not much. So you see that these two is the major leading public cloud providers. So still, AWS runs the most significant work, you might say that. the it also includes a plan to use. Okay? So then you might say, AWS is almost, but just a few years ago, always AWS leading a lot by a lot, and then Azure, and then GCP. GCP it has been always over many years. It has been on the third place. But it's sure actually. If you look at I put this this report on our reading list as well. I think I put 21, 22, 23. Let me double check. You can see how it has changed over time, but at least in terms of 23 U.S. Enterprises, that's what they say. Oracle, IBM, Alibaba, and what do they use? Platform, database, especially relational traditional database is at the top. And then NoSQL, Hadoop, data analysis, data storage, that's what they use a lot. Container as a service, actually less on VM, more on container. We're going to talk about it later, what container means and how it is different from virtual machine. But for now, just take it as it comes and try to have these words, sink in your mind over time. Cache, batch processing, search, streaming service processing, AI, and IoT. This is not so small either. Edge services. If you find anything interesting and want to comment on it, feel free to do that. Any questions, comments? The challenges, cloud challenges, what the enterprise organizations says that the migration it's pretty challenging. In fact, we have guest speaker from AWS. We have done it multiple years, and he also they talk about he's from AWS. So what they say, how the migration migration from the on-premise system to AWS, it can be easily done. Not easily done. What are the steps? How they guide those process? So they do that. Actually, the first thing it says is not migration. It says that managing cloud spending, it costs a lot of money. Yeah, so it's not really local spending. Security I think that's more of the concern, but still it's a challenge because that's one of the big concern, not just cost and management, technical issues, but also regulation policy, plus just the mindset. Is it okay? Everything was under our nest, and it's going outside. Especially for companies who deal with the sensitive data, is concerned on that. Lack of resources and expertise. That's why they are hiring people who have experiences on this, and who owns the data. Who can sell, manage data, things like that. So governance issue, compliance issue. We're going to talk about the related these policy issues, compliance issues, the HIPAA, and HIPAA is just one of them for health, the related data. But there are different concerns for different countries, the continents, like the European countries. So there are different compliance issues. Software license, migration is like I said, that the moving their software infrastructure and data from on-premise private to public cloud. So these are part of their challenges. The responsible unit, people who is going to do what. So that's another challenge they have to think about. And also many multi-cloud. they might be using already for data storage for different this cloud, and they want to use this analytics cloud from different providers, and how to manage multiple clouds. So these are the concerns or challenges this organization has responded. So between small and medium-sized business and enterprise, there can be slight variation there. You can see that the managing multi-cloud is an issue for bigger enterprises, and small ones typically they might do single cloud, right? And these are the cloud technologies they have used. You can take a look if you are interested in. This has a 22, 21, but 23 is not much different. So one of the tech trend is the distributed cloud. So what are the different styles of distributed cloud? Meaning multiple clouds being used on a distributed manner. That includes the on-premises public cloud, the vendor like AWS can offer private cloud to say government, and government may also have an on-premise, like especially military one, and that can be the hybrid distributed cloud that has to work with the public cloud offered by those the vendors. Other distributed cloud types include IoT edge cloud. Later we're going to talk about the edge computing, how it can be also useful for IoT. Like a sensing related tasks that are near the ground or near the where things are happening, and the coverage of the sensing would be huge or big. It's not just one source and do a computation. In that case, the edge cloud, smaller scale of the cloud with a computing and storage capability can be used, and later they can be connected to the big data center cloud. Metro area community cloud, like in the cities, actually there can be some distribution of the nodes in the area, initially collecting information, interacting with the citizens, and then ultimately data collected to the center, to public cloud, and the analytics can be done on the data. 5G mobile edge cloud, it can be offered by 5G or cellular network carrier providers. If you see on the road, you might have seen the cell towers, right? So cell tower can be also that's a geographically dispersed. It actually covers a lot of area, and that's the location. Some computing resource can reside and offer computing services. And that can also go in a global scale, where not just the T-Mobile or AT&T, but those companies can also cooperate with the international other carriers in different countries and offering global edge cloud computing services. So there are different so-called distributed cloud services can be offered. So this is this document is not necessarily technical document. This is a technology related, the big picture document for CEOs, COOs. This is what's happening. So at that level, of course, that's not our main purpose. But in the first intro overview class, we want to see that big picture. And 22, actually, this is not it's a more interesting thing. Rather than 23, it's a part of, it's not much different, but already 22, they saw the trend, strategic technology trends for hyper automation, you know, softwareization, automation, automation, you know, they, let's not do things in a fixed manner. So that's that has been already noticeable trend in 22. See, in 22 there is already Gen AI, automatic system, things like that, and hyper automation. You know, that was a part of it, and also security related issues. So the, you know, really already the hyper automation has been important strategy. So you know, try to avoid manual human interruption as much as possible, because often that becomes the source of an error and the issue of the scalability. So that has been the challenge. Now that has been the big picture trend, and let's look at let's step back and motivation really for the cloud computing, you know, in terms of usage as well as the technology. What motivated cloud computing? Why cloud computing? What's good about it? One of the first things is economics. The anything you have, even simple, not so costly one, if you were to make it by yourself, you know, can you do that with the money you spent on it? You know, even if, like, say, even $1,000, $2,000, you know, you have it. Can you make a smartphone? No, that you cannot actually do that, right? It really, smartphone, even simple bag or anything. Like, can you make a bag with $50? Somebody actually might do that, but in general, it's difficult. So really, economy of scale is a big thing. You don't raise a cow to drink a cup of water, right? You just buy it when you want to drink it, when, you know, as much as you want to have it, right? And you don't have a power plant in general in your home, right? You don't. When you travel, you don't carry all the cooking pots, you know, the food ingredients with you. So if you look at a lot of things we are doing now, the reason that restaurant can offer you a nice meal with, say, $15, $20, they oftentimes, sometimes you might be able to make it, but for your own one-person meal, that's it might actually cost more. But if you are serving for a lot of people, then doing it yourself might be more economical. So here the point is that if these providers, you know, the farm or electricity power plant, if they are doing this service for a lot of people, then you know, they can get the service at a lower cost, and also I get the profit as well. So it's really win-win when there is an economy of scale. You, rather than a lot of things, it's better to rent better, rather than buy even a house. You know, if you are staying for some area for 1 month, you don't want to go through all the hassle and overhead of the buying a house. And also hotel, the same idea. So public cloud providers really they rely on the economy of scale. They have a lot of big data center, have resources available, and rather than the dedicated resources, by doing the resource pooling, they can provide a good the service to a lot of users, and they get profit as well. So for the users, it's simple to start to use it, and the cost is a very low. Here the caveat is upfront, only in the front. You know, as I said probably many times, don't think that cloud is always a cheaper option. So a lot of companies they also realize that especially for security reasons, they have their own resources, and um, yeah, the cost can go up really high. Uh, so it's only it's low, but upfront. That's what they say. That's a good motivation for the users. The infrastructure installation, procurement, installation management, administration, it can also cost a lot, and it's all done by these public providers through the economy of scale, and it's a lower overhead for the users. The cloud computing, it's a general technology umbrella, we are not meaning the AWS, that's just an example. And the UMKC, we have our own data center, we provide the cloud services. So those are private clouds. And still, previously, it was all separate one. Maybe it could be in the older times in different universities, per department they have IT staff, they have all these separate, the management protocols and planning, all those things, licenses, all separate. But when we say let's offer them as a cloud, it's not just all over the internet. It's really all the integration of the different level of services together, and the here big driver is that resources are consolidated, even within one institution. Here the keyword is a consolidate, so IT functions can be consolidated. Even in the UMKC, UMKC had our email server. In network architecture class that I used to, I still occasionally teach, is that when I show the email, the mail format and so on, I could get into our mail server within the campus, and how the username can be changed, pretending it's from someone else. We cannot do that anymore because our function is consolidated under the UM system. So consolidation is a bit the cost saving for a lot of things, especially for
Isn't security is the biggest concern for public cloud drivers?
public clouds.
Actually, for public cloud drivers, when it is very low cost, the migration and this data storage it
Right.
is very less, right?
Right.
So for most of the AWS and Azure, most of them are using hybrid cloud computing. So why we are again using the public cloud more? Because many people are choosing for the economic purpose, but
So AWS, Azure, those are public cloud providers.
actually they are using the hybrid also, right? But most of them are the hybrid, right?
Most of them are hybrid, meaning they have their own, IT infrastructure. Actually, it's a good question. Why? And some of them is for legacy reasons. They are not completely changing from one day to, from one day from on-premise to public. And the security, the policy issue as well. In terms of security, in fact, this is the people might feel sometimes safer putting on the public cloud, an incredible public cloud, AWS, Azure, GCP, because they are aware of all the different policies that might be putting on the different types of data. So they might say, this is a HIPAA compliant and things like that. So security is actually the plus, and it depends. because for security it's really easy to say that, but there are different the aspect of security, confidentiality, authentication, the the authentication in different levels, right? So um, these public cloud providers, they have many functions of cloud already, and even the encryption functions they might use is mostly up to date, and some of the other private cloud, if it's not managed properly or up to date, they may not have a good security patches on even open source they use. So it is actually it depends on the plus and minus depending on the data and also the organization they might decide differently. That is a good question. So economy of scale is a big thing, especially for users, as we say, if we know there is ups and downs in the demand over time, without public cloud that can scale up and down elastically, what we have to do is that always a provision for the best one. Even in network, if network utilization is like at the 70% level, the people are starting to panicking already. They provision the upgrade. So they always have to maintain the over provisioning that can be really costly and leaves a lot of room. This doesn't show. There's a lot of room that is not, a lot of resources that are not really utilized. So if we just pay as we have used, as we go, then it can be more economical. The resources for the users, sometimes we might need a lot of users for a short amount of time, sometimes not much over a long period of time. And again, without this elastic, the pay-as-you-go service, we have to provision for the maximum. So in two different cases, the total resources we have used is basically the same, but the provisioning we have to have without this public cloud service, it's over here. From the provider's also perspective, purchasing, procuring, powering, managing machines at a scale can give a lower cost than the customer would do. It can also grow fast and actually pretty much it can be flexible, but there is some considerations how efficient it can be and what the cost can be if it can go up and down. As you have seen in the data center tour video, you see that they are actually mostly on a daily basis increasing their capacity a lot. I need to give you some time for a quiz. Let's do a quick So providers also, typically for the development, there are a lot of cycles in the development. Idea, just build it. These days, a quick, I hear conversation. What's the question? Okay, I'll give you the access code later on. Later. So the idea in this, rather than a lot of pre-thinking and then build it, ta-da! Here's a here's the appearance, show of our product, and then there can be a lot of problems. But still that's possible. Right, so rather than this going through one-way direction, typically these days, the product, the way it is made, that once there is an idea, quickly you build it and see what the people say, and then just fix it. They learn from the feedback and they fix it and improve it. that's those cycles. There's a business word for that. I'm blanking on that. So, yeah, the quick product you make it and give an iteration. In order for this to happen, all these cycles you need a different amount of resources, and you want to be able to be flexible, like quickly as possible. So the software distribution, you want to get it, you want to have it used by a lot of users immediately. How to reach a lot of users? You want to deploy it, right? So for those purposes, the cloud can be very, very helpful. So if it's really good for economy of scale, availability, it's good for users and providers, why it didn't appear earlier? Well, you might say, oh, I didn't think about it earlier, or I was too young to think about it. Well, it's not just a one person's idea. It's a really amalgamation of a lot of different things, different technology. It had to come together maturely. So relevant technologies were not there yet earlier in, say, 2011 or so. High capacity network, my PhD dissertation many years ago, it's a scalable, network monitoring in high performance networking. And the network performance has been always issues. Still, we have a lot more to improve, but it has come a long way. We can do Zoom, actually large scale. I do big meetings over Zoom. We had classes over Zoom up to 200, I think 300. It's the free version. You can also do more than that. That's thanks to not just software, it's behind the infrastructure. High capacity network has become available. The computers, the storage is also has become a lot cheaper, and that's a hardware technology maturity. In terms of that's not enough. You have a lot of computer where you can run Microsoft Windows, Mac iOS. That's not enough. We don't call that as a cloud computing. For people to be able to use multiple resources for a single task, and also do the multi-tenancy resource pooling, this virtualization is necessary. Right? That's for infrastructure, and on top of that, the services should be made easily available to a lot of users, and there is a software architecture that has been matured as a service-oriented architecture. You can do a push of the notification to a large number of people, can easily things like that. And the measurement of the resources, utility computing, and the things, the automation in computing has become also available too. So all of these relevant technology has become mature. That's why we have cloud computing. Finally, like almost 15 years ago or more than 10 years ago. And still, that's not enough. There should be users. A lot of maybe a few brilliant people have done all these things. Still, it wouldn't be here where it is now unless there are so many users that we have now. And that's thanks to the mobile device. We can do computing while walking, even in a train, bus, car. So plane still, airplane. It's not really easily available. But the mobile device and also wireless technology, the Wi-Fi, and also cellular technologies. All these mobile applications, they are naturally cloud-oriented. That nowadays it is almost like a computer. It has a good resource, but most of apps you are connecting to a remote server do all this work. It's naturally cloud-oriented. Where the cloud can do a lot of data storage and computation. And there are some interesting events that happened that, they made people, regular general audience, keep their eyes open, and things like this. An engineer at Washington Post Journalism, in 2013, there was a Hillary Clinton's travel document. A lot of pages were posted, and analysis. It could take months. It wasn't cloud computing, and he has done it using 200 EC2 instances, and we got the result within a few hours, 9 hours. And how can you get it done so quickly? Well, cloud computing. And people started, all these anecdotal events, people started to notice it. That's not also it. This prevalence of the data, not just the Hillary Clinton's travel documents, but these days, smartphones, there are so many low-cost sensors sensing a lot of data, and it can garner lots of interesting, useful information. Data everywhere at a lower cost, and we can do something about it. And the data has to be gathered together, merged together, and then we can do that in high capacity storage and computing node, and that's a cloud. So maybe I can just stop here. So technology-wise and application-wise, there has been killer application. Internet, I'll give you actually, I will let you do the quiz at home, okay? So, but we'll give you quiz access code. So the internet, how has it become so popular? And there has been, of course, technologies, but the HTML, HTTP is a protocol, but the HTML, and the user GUI. Previously, it was from University of Minnesota, go for text-based search, and then with a web browser, people can easily, search things. So that's the web was a killer application for the internet, and that killer application was really has been always important for this. When I'm involved in the 6G discussion and what would be the 6G killer application. So killer application is it's really critical component of the technology, the increase in terms of adoption, and we have it, mobile device and the wireless connectivity and big data, and so that's why cloud computing didn't appear earlier. Okay. We stop here for today. So the quiz, I had it due is like in 5 minutes, but I'm going to change it to midnight. The access code is a capital W2, week 2, W2. So let me just write over here. Please, week 2-ish one, I think that is W2. And let me change the deadline till the midnight today. All right. So that's it for today. See you on Thursday. Thank you.